Okay, everyone, welcome to the final project presentations for the Big Data and Analytics course. We are excited to have 8 teams present today. All teams have been spending quite a bit of time in building out their applications. You are going to be, the first cohort, which has exclusively used a lot of OpenAI APIs in this course. So I'm kind of excited to see what worked on and how much you've been able to integrate as a part of the whole application development. In addition to that, we're excited because many of you are graduating. Congratulations to people who are graduating, and also good luck to people who are looking for internships and co-ops. As you know, it is a market wherein there is a lot of interesting opportunities for big data and analytics related projects. So I've invited people to attend this presentation, and this presentation is being streamed live. So hopefully people who are watching these presentations, if they find that there are certain projects of interest and there are opportunities which may be of interest to you, they'll be able to reach out to you. So people in the audience who are listening to this presentation, if you are having any projects and you're looking for internships or co-ops, even full-time opportunities, please reach out to me and I will forward those opportunities to my students. They have worked really hard, and we were kind of timing how much they've been putting in. This project has taken close to around 600 hours of development collectively. 600 or 150? 150. Okay, so 150, not 600. So collectively, around 1,000 hours plus of work being put in this whole class for all these projects. So you're getting a summary of all the 1,000-hour project which has happened so far. The protocol is like 10 minutes. Students are going to be presenting, and then we're going to have a Q&A. The Q&A is restricted only to the class because this is a graded class. But if you have any project-related questions, or if you have any questions for specific teams, please feel free to comment online. That way we can reach out to you later and answer those questions, and maybe even reach out to you to do like a demo if you're interested to bring some of these ideas to your teams. So good luck to all who are in the classroom, and we'll look forward to your presentations. So teams, we have the links on the Google Sheet. We can come in and we can start presenting. Okay. So I'm going to share the screen. And you can go ahead with the presentations. Piyush, can you please make sure you time it? Sure. And,
Okay. Hi, everyone. Thanks, everyone, for joining online. We are Team 1, and this is our project that we've been working really hard since a couple of weeks. We designed a chatbot which will help job seekers by leveraging the NLP. And the name of our project is Crafting Intelligence Through Analytics, that we achieved using OpenAI. And all the application stack and everything has been hosted in GCP, and everything has been deployed. So let me just quickly take every one of you through our application and its capabilities. So this is the interface of our application. This is how it looks. And we gave a couple of options for the users to leverage the app. And except registration and login pages, everything was secured. If the user doesn't login until and unless user logins, all those pages will be hidden. Also, we implemented sending a nice invitation email whenever a user registers. So let me just quickly log in with my credentials and let me quickly take you all through our application. Yep. I've been logged in and now I'm able to see all the endpoints. Also, one thing to highlight here, we are using FastAPI, so everything has been authenticated and secured through JWT. And this is the chatbot. We developed. The really one thing that shook us while implementing this project is why not leverage NLP for job seekers and in job searching. So it's not just I will take you through the application. Let's say being a job seeker, I wanted to become a data analyst or data scientist in some specific location where users can interact with this app like interacting with a friend, and by making it more user friendly while doing their applications. So let's say I want to search for jobs in California to become a data scientist or data analyst. I will just quickly ask my application to fetch me some jobs so that I can apply. Please. Let's say Massachusetts. I don't know the exact spelling of Massachusetts, so I just type Mass. Let's see how our app functions. Whenever a user asks a question, it will quickly generate an SQL query so that it can fetch some results from our database, so that user can go into those links and they can apply. So these were the links that it fetched from our database. So these are the jobs that it fetched. Let me see. Yeah. That's what it does. Because we are implementing Langchain here, it's not just a conversational. It's not just static conversational bot. It also takes context of all the messages that were given by the user, so that it is kind of catching the sentiment of the user and fetching the results in that way. Let me quickly take you all through some other example. Like, can I get uh, let's say in Canada. Yeah, it will generate an SQL. Also, we try to imitate the state of art chart GPT. We display prompts in token wise. As soon as it generates some tokens, it will be updated real time here in the chart. Okay. Yeah, it generated the query and I see it is not able to fetch any results. That's okay, because there might be some spelling thing, because we are dealing with SQL. Uh, Yeah. So this is how it works. It will generate a SQL query and it will it will run that SQL query in our database to fetch some results. Let me just quickly take you through the charts so that user can know, the state-wise jobs that were being posted recently. As you can see, this is the heat map that we generated. We can see state-wise job count from our database. All of these charts were connected to our Snowflake database, and all the jobs were real-time and updated every day because we are running cron jobs through Airflow. And user can search multiple things like whatever they're interested in, like machine learning engineer and couple of other roles, and they can compare between which roles were mostly which roles will come out in more frequent manner and in more numbers. So this is one chart, and yeah, this is one other chart. Like this is the daily count. People can also see the real-time numbers, like in which days this machine learning engineering role has been posted, so that user can also kind of gathers the information on like on which months or which particular weeks there were most number of job openings, which most of the platforms doesn't offer, so that we implemented here. Also, I have two other developers with me who is going to quickly take every one of you with remaining features and the architecture and the backend of the project. Thank you, guys.
Okay, so good evening, everyone. I'll be walking you through some additional functionalities of our app. So this page is called as the Network Explorer. The idea behind this page is we have tried to scrape people from Fortune 500 companies from their domain. And the reason being, we wanted this application to be a one-stop application for all the students, where if they are going to any of the website, they just don't have to search for jobs. If you want, in today's market, we know what value networking brings. So if you are applying to any application, if you have hand in hand any vice president, manager, or hiring managers LinkedIn profile, you can just directly contact them. So this was the basic idea behind developing this application, developing this page. So you can see this, we have taken the list of companies from Fortune 500. And if you go, you can see there are multiple people from all over the world. You have their LinkedIn IDs. You can directly go to their LinkedIn IDs and send a request if you want to. And currently, we are limiting this search for only 3 companies. So you can see if you select 3 companies, all the people and their IDs will be displayed. The reason we are doing this because the application that we have developed right now is a B2B or a business-to-business model. Now, I want to talk to you guys about further enhancements. So how we can make this model a business-to-client model. So there are 2 things. Firstly, I'll walk you through the Network Explorer thing. We have added this functionality called upgrade subscription. So since in the networking AI page, we have only given them access to 3 companies. If you want to access more than 3 companies, they can choose either of the subscription. One being where you can search for like 5 to 10 companies, and the other being platinum. This is still in the working stage. We have developed the logic, and what we are trying to do is when you enter the card details and submit a payment, we'll be using Stripe API that will process the payment. Once that is done, through FastAPI, you can get the user credentials and you can upgrade your plan, and you can search for multiple companies at the same time. The other feature that we have tried to implement is resume passing. With the help of the Langchain, firstly, you'll be able to upload your resume. And once you upload that, depending upon your experience and all the skills that you have, Langchain will be suggesting you jobs. So these are the future enhancements that we are planning to do in this app. Now, let's come to the Dockerization and deployment. We have deployed our app on Google Cloud Platform. And regarding the continuous integration, we have deployed the cron job to the Airflow scheduler on the GCP. And whatever data that we are scraping, not just for jobs as well as for the network UI URLs, is getting loaded into the Snowflake database. So that's a continuous delivery of the data. Now, my friend Saroj will continue.
So going ahead with the backend of the project and the architecture, we have used Airflow for continuously integrating, like loading the jobs into the database, and we are using Snowflake for the database thing. So going ahead with the architecture diagram. So once the user enters the question, the question is transferred through FastAPI to the Langchain so that it converts it into a query to API, OpenAI's API. Then that query is run into the Snowflake database, and we get the result on the Streamlit application. And going ahead with the backend of the project. So Airflow, what we are doing is we are described 4 tags in Airflow, that is data scraping, cleaning. Then we are loading the data into the staging table as it's a safe practice before we load the data into the main database. And then we are merging our staging table and also the main jobs database so that there are no duplicate values there in our main database. So for scraping the jobs, we are using Selenium as it's a as beautiful soup wouldn't work well with the extraction of the jobs from Indeed and LinkedIn. And also the Selenium was not getting the remote web driver. So we have also Dockerized the whole thing, and we have also deployed it on the Google Cloud platform. So this was the architecture and also about the backend of the application. Thank you.
We can proceed with the Q&A, Professor.
Okay. So the blocks which were kind of listed, I didn't understand like the interaction with data.
Yeah. So I want to see machine learning jobs in some particular state. If I search that in my message, it will from the question I asked, it will generate a SQL query because it has to fetch some data from the database so that user can go into that link and apply to that job directly.
No, but I thought this was searching directly online, no?
No, Professor.
So it's searching from a database.
Yeah, it's searching from a database.
So you're generating the SQL.
Yeah, we are generating the SQL, and SQL query will be run on our database.
And those jobs are real or?
Real.
Yes,
Every time.
every day. We have put the cron job so that every day at 12 o'clock, new jobs will be scraped and appended into the original database that we have. So user gets the updated jobs.
Okay. And you're using Indeed or just
So we are using
LinkedIn and Indeed.
both.
And the old jobs or the jobs which expire, are you removing them? Or?
Yeah. After 30 days, jobs will be removed from the database automatically.
Okay. So this doesn't have any kind of Pinecone or anything. Is this?
No, we are not using vector database because we didn't see anything to cache because it's not a static bot, so that it can retrieve something.
If there are no jobs which has like software engineer in California, very real.
Yeah. I mean, let me query again, first.
It's like saying there are no burgers in McDonald's.
No. Submitting person sign. That's the reason why. Okay.
What's happening?
Yeah, I mean, because it's fetching data from the database. If there is any discrepancy in the query, it is not able to fetch the results. It is generating this percent, and I tested this vigorously, but it didn't happen when I tested it. Why it is?
So none of the queries are working.
No, in the first query that I asked, it did work. Because user will be asking different questions every time, we need to close the connection. That's the reason why whenever user asks the next question, the table will be removed. In the first query, it did it did displayed some tables. I will show you this. Just give me a moment. This is the table, and these are the links, so that you user can directly go into that link directly and apply.
So, thank you.
Yeah. Thank you so much, guys. Thanks, everyone.
So that was team one. Let's go to team two. Close the volume window.
Yeah, sure.
That's the ones you have. Don't close the.
Yeah. Thank you.
So hello everyone. Today we are here. Myself Shardul Sawan, and here are my fellow teammates Dhaval Negi and Chinmay Gandhi. Those are the data engineers and application developers who have developed this application called NewsSphere, where we are using AI-enhanced news digest platform. It offers simplicity for users to consume the news. And what different is there in this application from the news aggregator application that we use in daily life is that we get to personalize our news feed. So a user can read, also listen to the news, and also organize their news feed, which comes from the trusted sources, news sources. And moreover, a user can, in this fast-paced world, user can save its time by listening to the news instead of reading the whole news. Also, a user can perform voice-based search, and also could listen to the news, add to the queue, and add to the playlist to come again and listen to that audio playlist of the news article and the summary. So further, we would go through the demo of our application. Chinmay will go through it.
So this is the application. We'll quickly register ourselves first. So here there are various categories available. So I'll select health and I'll register ourselves. Now after registering, it is asking me to log in. So once I'm logging, as you can see, we are getting all the latest articles related to the health. Okay, these articles are coming from our database. Our database is getting updated with our articles, the latest ones, every 8 minutes. Okay, so now let's say you want to read something out of apart from health, you want to search something. Let's say I want to know what's the weather in Boston. So I'll click on start recording. It is asking me for microphone access. I'll allow Boston news. So did you mean this Boston news? Yes. So I'll click on get news. So here we will try to get all the all the articles related to Boston news from Google and show up in the home page. So as you can see, not only we are giving the articles, we are also giving a summarized content of all the articles, all the 5 articles that we have, so that if the user
does not wish to go through each and every article. So the content includes information about an exhibition in Massachusetts Historical Society, blah, 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 etc. has been written. And apart from that, you see, here are the articles which have been directly fetched from Google. Okay. Now, based on the search that has been done here, we are recommending suggestions also. And these are the articles, which are the latest articles, which are from our database. Okay. Similarly, let's say I want to pass a text input. So like Google Gemini. Okay. I'll click on Get News. See, so our application has fetched a summarized content that it is recently developed a large language model that outperforms OpenAI's model in text and image understanding, etc. These are the articles which have been fetched from Google, and these are the recommended articles which are coming from our database. Okay. Now, let's say you don't want to read the article, so you can just play the audio output.
A researcher who has studied the icy world said the prospects for the development of life are getting better and better on Enceladus.
Okay. Now, let's say you want to access this article right now, and like you want all the 4 articles to be read, all of them once together. Okay. Now I'll add it to queue. Okay. I'll add this one also to queue. Okay. And now we will play the entire queue.
Hello, this is your queue. The justices announced that they would hear a case challenging a federal agency's approval of a commonly used pill. The next article, congressional investigation found that the nation's largest pharmacies have handed over prescription records to law enforcement without a warrant, raising privacy concerns.
So our queue mentioned that this is a queue, and when the next article shows up, it mentioned that this is the next article. So basically, if I don't want to access it later, I will just add it in a queue and play it. So that let's say if I'm driving and I want to listen to the news, so I'll do this. Apart from that, if I want to add it to the playlist so that I want to access these articles in the future, so what I'm going to do, I'll click on add to playlist. I'll add this one also to playlist. Okay. And I will create a new playlist. Playlist 1. I have clicked on create playlist. The playlist has been created. So as you can see, it is showing me all the existing playlists also. So I'll click on show playlist button. Now I can similarly play the article one by one over here. Or if you want, you can play all the articles together also. Similarly, we have given an option to delete the playlist.
A congressional investigation found that the nation's largest pharmacies have.
So this is the overall demo that we have.
And like here we have given option to the user to like manage his profile, add his preferences, create his own playlist. You can modify the playlist, add new articles. Like let's say I'm building a tech related articles playlist. So I see 3 tech related articles today which I want to refer later. So I'll add them to my playlist. Tomorrow I come back and I can add different articles to the same playlist so that playlist keep on increasing. Yeah, can you go to the architecture diagram? Yes, so here is our architecture diagram. So we are using major news agencies, and in the major news agencies, we are pulling the data through their RSS feed via Airflow pipeline. Airflow pipeline is hosted on Google Cloud, and that Airflow pipeline scrapes the data from RSS feeds, do the data processing on them, and separate them into create the embedding for those articles, as well as store the articles in our SQL databases on Azure. And here is our front end user. The application which user uses, which is hosted on Streamlit Cloud as well as on Google Cloud. And through Streamlit user creates his own profile, logs in, manages profile, creates his playlist and everything. And there everything is done like Streamlit refers to our FastAPI for all the access to our databases as well as OpenAI and GNews. And GNews is the library which we are using to fetch the latest article based on the user search query from the web. User do a query, we search on Google News, we process the result from the Google News and make a call to OpenAI to generate the summary of those articles and render it back the Streamlit. We are also using the GTTS Google text-to-speech library to convert the articles into the speech format. And we are referring the articles back from the SQL as well as Pinecone for the recommendation. Yeah, and we have also done the CI continuous integration related when a new code is pushed to our GitHub or test written in PyTest using PyTest library runs on the GitHub actions, and the new changes in the FastAPI, since the FastAPI is main core backend of our system and everything is integrated via FastAPI in our front-end application. We wrote tests for FastAPI to be tested for each and every cases we have and API calls we have. Thank you so much.
So the audio, is it just using this phone or what is it?
No, so we are not.
So we are using the Streamlit widget, that is speech to text. We have got it on the GitHub.
Okay.
Streamlit widget.
So Streamlit has its own tool to convert, like access the microphone of the system.
Yeah.
Get the input in bytes format, convert it into text format, and then like for converting text to speech, we are using Google text to speech language.
And then for the OpenAI, what are you using OpenAI for?
So as and when users search a question, like when you go to a Google or any newspaper, you search a question, you get a summary of what question you asked, right? So we want to summarize what we want on the web for you, so that you don't have to go through each and every article separately to find what you need. That's right.
Yeah, so we are getting the top five news, and then we are taking the articles.
Summary out
And-
based on the user question, and then we provide
Okay, so instead of going to 5 different
article to find your answer, we are trying to provide it through a summary.
Okay. Okay, and is it just a one-shot kind of a thing where the user says, oh, I need more information, and it will also use your form or something like that, or it's just stuck to the links which we bought for this.
So RSS feeds are the like set of links which we are using to like which covers BBC, CNN News, New York Times, and all the major news vendors. But for the Google search, we use the user query and ask the Google to like provide a specific article. So it's similarly what you do, go to Google and type a question, what list of articles you see. That's what we get in response, and we process them to show them. So based on what prompt you provide to a search engine will be the response.
I didn't understand so you go to Google, you search links, and how do you try to RSS feed?
No, the Google search and RSS feed is generally like when you create your profile and set preferences. Let's say I want to know every day when I come to your app, I want to know about tech and health. So when you log in and you haven't searched anything, but you want to see something and just want to consume news, we spend like we recommend you 10 top articles based on your preferences. That time we're using RSS feeds, and which is updated every 8 minutes.
Oh, thank you.
Thank you so much. Thank you, everyone.
Okay, next name, please.
Google login. Yeah, I just. Thank you so much, everyone.
Hello everyone, we are Team 3 and our final project is personalized healthcare recommendation system, and this is our GitHub repo. Let's just go into the demo. So this is our main homepage. You can see the patient guide and patient sign up pages over here. The patient can sign up by giving the first name, last name, age, insurance. So all of these are necessary for us to do our analysis. So if you do not enter any of these fields, it's going to show an error. And over here, you'll be able to select your health insurances. That is, you can select whichever health insurance that the patient is having. And then this is the doctor guide, and this is the doctor sign up, where they'll be able to sign up as a doctor. So this is the sign up page, and in the about page, you'll be able to see why you can use our web app and how is it going to be helpful to you as a patient or a doctor. So let's just do a quick demo for the patient. So this is the navigation. It will tell you how this page works and how to use it and everything. So let's just give zip code. And over here, you can give any additional information that you have. Sorry. So this is the initial diagnosis. So we have asked OpenAI to give the hypotheses that are most related, and the first one will give you the highest probability. That is either a common cold or sinusitis, and the second and third hypothesis. And from the symptoms, you can see that all the three hypotheses are the same, meaning that it's very definitive that this could be the initial diagnosis. And if you click on doctors,
And one more thing, the diagnosis that it's giving right now, it's not the 100% accurate one. That's why
yeah,
we
even when
mentioned
you
it
are
as.
giving in the hypothesis, we tell you that in order to get a definitive diagnosis, it's better if you go to a physician, but this is according to us from the symptoms that you are given. It also helps us if the symptoms that you're giving is as elaborate as possible and explains as much as possible rather than giving something really vague and opaque. So these are the doctors according to the diagnosis that we have given. So over here, we are taking your insurance and the zip code. So these are the doctors closest to your zip code and that accepts the insurance that you have given. So here you will be able to see the details. If you click on this, you will be able to like go to the Google Maps where you will be able to find the doctor, like the address that the doctor has given, and you'll be able to book the appointment over here. So this is for the first. So Autolag, sorry, I don't know how to pronounce it, but it looks complicated, but it simply means an ENT doctor, that is ear, neck, and tissue doctor. And the next one is going to be internal medicine, that is like home medicine, and the next is pediatrics. Here you'll be able to see the patient details, and as you can see, the age is 24, and technically they are valid for pediatrics to deal with them. And you'll be able to see the doctor details over here too, all of them.
So all these doctors are recommended based on your symptoms which you have entered as a patient and the nearest doctors which are available for that particular zip code. So 02115 is a zip code entered and all the doctors nearby are listed here. And similarly, if you click on hospitals, you can go ahead and check the nearest hospitals.
And one more point to mention over here is you'll be able to see all the doctors. And if you again click on here, you'll be taken to the the hospital Google map. You'll be able to see the address and the city and zip code and everything. So this is the patient demo. Moving on to the doctor. Oh, sorry. Please don't forget to log out. So this is again how to navigate the portal, and this is the doctor details. And the symptoms, let's just give something like fever. No additional information.
Okay, so for the doctor, we have given two features over here. The doctor will be able to provide the symptoms of the patient just for confirmation. Then he'll also be able to provide what kind of treatment can be provided to that patient based on his symptoms and the initial diagnosis that the AI will give. So here we will be able to see the diagnosis and recommended treatment. So this is the portal for the doctors.
You take another symptom, if I give it as heart attack. So it clearly shows that diagnostic information, electrocardiogram, echocardiogram.
So based on this, we can, it says that the diagnosis can be made through electrocardiogram, and the treatment that can be provided for this anticoagulant blockers. So it provides some kind of recommendation to the doctor based on the symptoms of the patients.
So this is the portal for the doctors wherein he can recommend based on the at least he can come to a decision that this is something best which I can give to my patient. So this is the
And one more point to be noted here is the main specific function of the doctors is that it will be able to identify infectious diseases more accurately. So the doctors will be able to diagnose heart attack, old age and everything. But since we have more than 300 and 400 infectious diseases in the entire world, if you give symptoms related to the infectious disease, it will accurately give you the diagnosis and also the treatments related in the similar way. So the main use case is to identify infectious diseases and how to treat them accurately.
And one of the requirements over here is it will give you more accurate result if you provide a more detailed description of your symptoms.
Okay, and coming to the code lab, so this is our introduction. Okay, this is our architecture diagram. The first one is for the patient and the second is for the doctor. So patient is pretty straightforward. We are using RDS to store the patient and doctor credentials. We deployed Airflow, and Airflow is going to scrape all the data that we are using over here. We are scraping from MassDoc for the doctors. We are scraping from Wikipedia for infectious diseases. And as we mentioned during our project proposal, we were scraping our patient data from the Massachusetts Government Hospital, where we were able to get the access from, and we took the patient details from there. And all of this Airflow is going to scrape it and put it into the S3 bucket, and we're going to do it every week. And the Snowflake is going to take the data from S3 bucket, it's going to clean it, format it, model it, and build the tables and views that is more appropriate to the project. And we are going to use FastAPI to query the Snowflake and also to interact with OpenAI, and basically it acts as a connection between Snowflake and OpenAI. And in the Streamlit, the patients and doctors are going to give symptoms, details, and all the necessary information, using which FastAPI is going to give the necessary answers after communicating with OpenAI and Snowflake. And the Snowflake and Airflow, we put it in CI/CD. So if you just trigger the GitHub, it's going to build up the entire Snowflake database, and the Airflow will be triggered. So let's see. This is how the database is going to look once the CI/CD is done. You will be able to, this table will have all the raw data for your reference, and this one is going to have all the clean formatted data that is necessary for the project. And that's for the patient. Now moving on to doctor.
Yeah, coming to doctor, so when patient enters his details, it will be given to okay, in the backend, how it's happening is since we're scraping the data from the Wikipedia, all the data is extracted and then converted and then the embeddings are stored in S3, and then from S3 we are pushing it into the Pinecone, and the embeddings are stored in the form of vectors, and then we are performing a semantic search on the Pinecone using OpenAI, and then that is how the based on the top similar matches, the diseases are the treatment recommendation is being performed here using OpenAI. So this is straightforward logic for doctors. And then how
in the code labs, there is a detailed description given on how to run the application, where to get the data from, and how it's supposed to look. And you'll be able to find the Airflow, Snowflake, and all the links over here. And this is the data source from which we have scraped the data and got the data from. And the navigation and everything for Airflow, Snowflake, FastAPI, and Streamlit, everything is given over here. So during our project proposal, we got a question of how we are going to use the zip code logic over here. So Ritvik is going to discuss about it.
So one of the ways the way that we've implemented here to recommend doctors based on the patient's location is using something called Haversine formula. So we were able to get a database that provides the zip codes and corresponding latitudes and longitudes. So based on the patient's location and the closest match to doctors, so we will be doing a semantic search and getting a list of doctors that can treat this. So based on the patient's zip code and the available doctor's zip code, we are finding the closest one to our patient. And the closest top three or the limit that we've set will be displayed to that.
So what was the use of OpenAI?
So for the first part, patients will be providing their symptoms. So it might not exactly be professional way of giving the symptoms. So if we do a semantic search, we will not be able to get the 100% accurate or somewhere close to that. So we are taking these symptoms and providing the list of specialties that we have to OpenAI, and it will categorize it. It will select the best specialty to
It's
treat
going to
that.
sort it according to the most related specialties, and we have the huge 33.2K list of specialties in all the data set. So we are going to give the symptoms and the specialties to the OpenAI. We have given pretty specific prompt, and the OpenAI is going to sort that data set what we have given into the relatedness of it. We have the first three, and in the first three from the database, we are showing the first three doctors that takes the insurance and that closest to the patient. So that's how the OpenAI works with the first part, the patient use case. And when it comes to the doctor use case.
And for the second part, we're just taking the symptoms, creating embeddings for that, and doing a search with Pinecone and providing the most probable disease treatment for that symptom.
So it mostly depends on the data.
Okay, thanks, guys.
Thank you, everyone.
That was team 3, and we're gonna have team 4 now. So team 4, I believe, had some technical challenges, so they're going to do a video.
The problem we had was that unfortunately our keys got leaked. So we made a repository private and we launched a VM instance again and we pulled our code, everything again. So that's why our repository for now is private, but we are fixing that. We have a YouTube video as well, but we want to show you live demo of our app. So we are trying to do that right now. Right, sure. Outside.
Yeah, so we are team 4 and our topic is personalized fashion discovery. So in day-to-day life, we see a lot of clothing types or photos on social media, which we like, but it is very difficult to explain that in words, which is why we came across a solution where we will upload an image and give the similar images back to the user. And the other amazing feature of the application is that the user can chat with the chatbot, and based on the responses that the user gives, so the chatbot will give the similar images based on the description that the user provided, and the user can see all the similar recommendations that the chatbot gave to it. So the Devesh will take over.
Devesh would give out a demo for the application.
So primarily in our Streamlit, like our target roles were like there would be multiple buyers and there would be a single seller. So there are 2 roles in our app. So the buyer would just log in. Norman, can you go to the store owner or catalog manager? So what we found that like where this idea came from, that we went to Zara's website and we found that there's only a textual search format there. So a user cannot upload an image to go through the product catalog and find the most relevant item. So we thought of like just building a POC for that, a tool for that. So this is where our product comes in. So this is what we are doing. We are doing an image-based search. So the second one is this is where the catalog owner will just perform like do upsert operations on the Pinecone, and so we have done some validations as well here. If if the seller wants to update his catalog with you say, for example, he has got like 5 new products, so he'll upload a CSV with five of those 5 records, but he also has to upload like 5 new images along with it, because every product must have a product image associated with it. So this is where that the validation part. So we have also given him the opportunity to perform delete product and everything. So now comes the main part, the buyer part, which so Naman, can you log in?
Yeah, so two major features in this: the chatbot, which basically gives the product results based on the text that the user gives. This is based on chatbot is based on the Langchain and OpenAI together, and ultimately we are converting the embeddings using OpenAI's clip model, which is ultimately like helping us to communicate between images as well as the text together. So let's say I'm asking for I want to buy a shirt, and the chatbot would next ask what do you have any specific requirements? So I can give maybe a specific color, or if I'm looking for a formal shirt, let's say, or something. A white formal shirt. Okay, let's say for a movie night, let's say. So although our catalog is limited right now, so let's see what kind of results do we get. So it was able to give us results with the shirts which are white, and we have some metadata along with that, with the more of the colors in that, or what category it comes in, and the way we scrape the data from Amazon, we could find number of reviews or ratings and the number of sizes and all as well. So we are giving information of that. And the same way when we come to image search, let's randomly download a random image from Amazon, let's say for shoes. Yeah. I can upload that JPG shoes file over here, and it would be able to give me the similar kind of shoes. Well, the same exact one was available in our catalog as well, because our data has also been scraped from Amazon, and we can look for more products as well, which are similar to it. And if there is a specific one that user likes, they can add to the wish list as well. So coming to the architecture of this, we have 2 application roles for the user and one for the vendor. The user can log in or register for the first time and gets authenticated using JWT tokens and FastAPI. Then gets to options to either search by text for the products or by image. If there is a text, the chatbot is based out of Langchain and OpenAI that gets involved over there. And for the product directly, the image gets embedded using OpenAI's clip model. We are ultimately storing that into like all of the embeddings have been stored in Pinecone. So we're querying using Pinecone's cosine similarity search itself over here. And based on the product IDs, fetching out the product details from Amazon S3, especially the images and the metadata from Pinecone itself, which gets displayed over the Streamlit. The same way when the case goes for vendor, we have the delete part that directly communicates with the Pinecone to update the catalog.
and when it comes to adding or updating the products, that's something which can be done by the vendor in a batch. So the vendor can upload a CSV with a certain template of it, with all of the listed information of all the products and product IDs along with the images. Through S3, we have a censoring trigger ready on the Airflow to whenever there is any update on the S3, it triggers the pipeline and ultimately generates all of the image embeddings through OpenAI clip model and ultimately upserts them into Pinecone. After that, we are doing a short Python script to send out an email to the vendor as well that the products have been uploaded. All of this has been Dockerized and has been deployed on GCP's compute engine. Coming to the data source for this, that's like I said, we scraped it using Scrapey library from Amazon itself. We have a catalog of around 3,000 plus products right now in that. And the specialty with the, I'm pretty sure many of us wouldn't know about this, since that's something we haven't really experimented before with. So this is OpenAI's model itself called as contrastive language image pre-training. It parallelly trains the image embeddings and the language embeddings with the vision transformer and the transformer model respectively. Ultimately, all of the dimensions for the embeddings are same as 512, which makes it more feasible to have them together in the like query all together in the database. We also have some tests that we did for the Streamlit and Pinecone and Airflow. That's something we can go through later. I'd like to explain some test scenarios. So we had some scenarios that we tested with generally the features of the application itself. Like I uploaded an image of a boot and tried to find the same kind of boots available. The same way for the text, I was looking for a casual T-shirt, so I could find results like that, and then like uploading our product catalog. So updating a product catalog. So in this first one, you can see a green mark over here that products were uploaded, and here it just failed because the images were not uploaded. So yeah, we had some scenarios like that.
So the clip model, so how is it deployed?
So we are directly installing it in our VM instance with the tokenizer and the model itself. We tried with APIs. There are some companies, although it's not directly from the OpenAI as an API. There are some companies like Ben2ML and there's one more that I don't remember the name now. We tried that, but those were not very trustworthy. Like while implementing, there were cases when it's not connecting to the API. So we didn't wanted to risk that part. And anyways, we were going with the VM, so it was still safer to install altogether at that point of time.
Okay. And you have only one VM hosting everything?
Yes.
And the FastAPI is also there, so that you can use FastAPI or like.
Yes, we are using FastAPI.
So you're just basically posting the hosts in the firewall and hosting it and accessing the whole ports on the same machine. How are you kind of connecting the frontend to the FastAPI?
We are passing the like in the Docker Compose file, we have linked it to the front end and the back end. So in the front end part, we have just given the link that the back end is hosted on. So like that, it is being linked.
The front end and back end are all the same.
Yeah.
Yes. That's what I was like. You're running probably on different ports. So.
Yeah. So we are just providing the link.
Okay. Cool. Thank you. Next team, please. Can you give them screen share access? Huh? Try to get to that later, but, next team, please. So team Y has a couple of challenges, so we're going to go to team 6. So is your beta private or what, for example? So your team 6?
Yes, yeah.
What's the project title?
Helpobot Explorer. Helpbot. Explain what.
Hello, we are Team 6. So we are here to present our final project on Elfobot Explorer. So we know there are many restaurants, there are many eateries, and there are not many businesses who know how to handle the data. And we thought of that, and we thought of creating a platform wherein we can present analytics to the business analysts who can basically perform search operation, might as well chat with the code to get some meaningful insights out of it. So thinking of that, we have a few use cases. So suppose a user comes in and he thinks of an occasion. So user has an occasion of some corporate event, let's say, and he's really confused of what to go, which restaurants to visit or what to have. So he'll just use our platform, and it'll be a very easy way to just suggest restaurants for him. So likewise, a business analyst who is looking to open new businesses around places, so he'll just investigate or rather do some few analytics based using our Elfobot Explorer. So here's how the presentation goes. So as of now, we are currently operational in Pennsylvania state. So
Yeah, and the data set was quite huge, so we have just restricted for now to one particular state. Also, this is a Streamlit UI where we have the search, chatbot, analytics, and logout pages. Initially, we have the sign in and the admin page. So we have signed in as a user here. So yeah, Vivek can go ahead.
yeah, so this is just a basic semantic search. So user can just select city as Philadelphia, postal code is open, yes or no, and you can search.
So basically, this will list out all the restaurants based on the filters provided by the user. So if I want to search what are the restaurants which are available on on my pin code or near my pin code, so I can simply enter my pin code, my city, and all these details, and it will fetch out all the restaurants available.
Yeah. So if you're still confused, we have actually formulated a very personalized filters for you. So let's suppose you have some theme for your restaurant search. You would like to go something with cheese, or maybe weekend getaway, eat away, pizza time, anything. So you can just hit the results, and you will have the top restaurants. And this is formulated as in like top rated, highly rated, and above 4 stars restaurants.
Basically, this is just the plotting of the restaurants on the map, just to highlight where are the what is the exact location of the restaurants that we have filtered out. So,
Yeah.
Going to our chatbot, we have developed our chatbot using the reviews from the restaurants, and we are storing it in Pinecone, and we are trying to basically query those results, and a user can ask questions and get certain results with respect to what the restaurant provides. Maybe we can show you a few examples here.
So we thought of going with review data basically because review we did some data engineering on that, and we thought we can get more context and more personalized suggestion from it, and maybe we can feed it into a chatbot by generating embeddings first and loading it into Pinecone, and then having a connection with Streamlit via chat completion model. So in that way, we can present a full end-to-end chatbot functionality to user, and the user can query out anything.
So here,
So that's our chatbot functionality where user can query certain results and probably get some displayed outputs. We're moving on to the analytics dashboard where we have displayed the density of.
yeah, I would like to go. So in the analytics dashboard, this is the density of businesses. So for now, we have just Pennsylvania state. So if we see, we can just scroll down. So we have just plotted down all the points on the graph. On the map, if we just hover over a point, it will show us the restaurant name, the address, latitude, longitude, and all the other details. So this is one of the pages on the analytics. Now I would like to go to the second page, which is category popularity. So if someone who is a user of our application wants to know like what are the businesses or restaurants that are famous, this as we show. Currently, it shows the analytics of the entire Pennsylvania state. So there are number of like 12,641 around restaurants. Now I can filter based on specific cities as well. So if I just select here Philadelphia and click on search. So it will restrict down my search based on that, and the data is directly coming from Snowflake. And if it's so this is like basically a user can further dig down based on the postal codes, and they will get basically the main idea was to let the user know where the restaurants are highly located, like densely located, and what kind of. So they can just simply select the city and the code, and it will show them all the analytics like restaurants, foods, shopping, and all those. So if you go to now like restaurant specific cuisines, so here user can give a zip code. Now here we have also mentioned the radius. So basically user can give any value here, and what kind of cuisine or food the user is looking for. So simply for now I have like they've given by defaulted values here. So we just if user is searching for, if the user zip code is 19107 and he's looking for restaurants within 10 miles and he's looking to find Indian food. So he can simply enter these things and click on the find restaurants. Basically, what it will show, it will give us the best restaurants based on the rating by the based on the users values entered by the user. And here we have basically tried to highlight the user location with the red dot and the restaurants around him, but we have tried to fetch up the best restaurant based on the ratings here. Like basically we have tried to showcase the sentiment analysis here. Like I would like to go to the recommendation page. So here we have tried to come up. So basically the end goal was to tell. So if a user want to open a business on a particular location, we should be able to at the end it should give the user some kind of information based on certain data where he can open a particular business. So if we just select, we have here the drop down list of all the cities here. The user can select a particular city and what kind of category, like the business category he's like he wants to know the recommendation for. So here we have just entered Indian, like Indian restaurants or Indian cuisines. So it will try to here the data what we have tried to list down is based on the postal codes. We have tried to come up with the average rating and the total reviews and the number of business counts in that area. So the idea was to show the user which postal codes like the ratings are very low so that the user, the new business owner, can go and target those areas to open a new restaurant there, because there will be more chances, because the ratings are quite low of the Indian restaurants over there. So people might, if they have food over there, they might, most probably they won't like it there. So this was the idea of giving up the recommendation over there. So this was basically pretty much it for our demo. We have tried admin page and all those things, and everything is JFT secured. So if we just go to, I will go to for the code labs. How we can. These are all secured endpoints, and we'd like to go with the code labs. Oh.
So coming to our architecture diagram, our whole application is deployed on Google Cloud, and we've Dockerized all the, we've containerized all the applications. We are fetching all the data from Yelp database, which was updated 2 years ago, and then we are taking Yelp Fusion APIs, which we are updating every day. We are extracting the new businesses and the reviews, and then we are storing the embeddings of the reviews inside Pinecone database. And then we are querying our application from Snowflake and Pinecone. That's one of the business problems that we're trying to solve, and that's.
So, where is OpenAI used?
So we are trying to fetch the reviews from the Pinecone database, and then we are trying to generate the answers based on those nearby locations, reviews.
Just for that.
Yeah.
Yes.
And also we've used Langchain for communicating to Snowflake database, like in our assignments.
So the personalized search that I just showed, it's basically the querying against Snowflake and getting the results, the data frame.
So all the analytics that we showed is directly all the data is coming from Snowflake. So every time once the API hits and new restaurants or information are added into the business and other tables, basically the graphs will also get updated based on the data, new data which is coming. So the main idea was to come up with something so that a business user which is using an application should know if he wants to have an idea in a particular location, what are the restaurants that are famous, or if so at a particular zip, if he wants to know whether Indian restaurants are less or more, or what are the ratings or all those things, and if we can come up with a to a point where you can open a particular restaurant in that locality or not. So we have tried to come up with a recommendation for that.
Like Yelp already has these two kinds of platforms where it offers businesses an opportunity to open their own business inside Yelp so that they can marketize it. And then so we are trying to basically help the businesses to locate that particular spot and then a user. Thank you.
Thank you so much, everyone.
Okay, guys, next team. Team 7.
Hello everyone, good evening. We are from Team 7. I am Aditya and we have Udhav and Nidhi along with us. The project which we built for this course, the name of it is Health Plan IQ. The motivation behind creating this project was because we all know healthcare is very important. More so ever being an international student, we realized the importance wherein one of our friends they got sick and they had to incur most of the expenses by themselves. So this led to the idea about how the insurance plans work in US. So as per our research, we came across this thing like healthcare.government, a USA based website. They on a yearly basis release different insurance plans and the premium rates, the insurance issuers who give those plans. So the thought of if we could have a useful chatbot application to which a user could simply ask natural language based questions and then get answers. So this chatbot acts as a easy interface for the user to get his or her questions answered about the insurance plan. This was more about the project. I would like maybe to take us to the architecture.
Hi, everyone. So as Aditya mentioned that we are getting the data from the official government website of the US government. So as we can see on our screen, we have like different formats of the data. We have the JSON data, we have CSV and Excel. So what we are doing is we are creating different Airflow pipelines that basically scrape the data from these sources, these URLs. And then the Airflow pipeline is responsible to clean the data, manipulate the data based on our requirement and the use case. Further, the Airflow pipeline uses the GCS bucket to kind of store the intermediate data and the pre-processed data that we have, which again acts as the external stage for the Snowflake to pick the data from. And in the Snowflake, we have the stage and like the stage schema where we have all the raw data available. Then we have different schemas based on our requirement, where we have the analytics schema based on the use case that we wanted to perform. Then on the front end side, we have the Streamlit application that is responsible to take the input from the users, like the questions and the queries, which again uses Langchain and OpenAI to give back the responses. Now I would ask Uddhav to present us the demo.
Yeah. Before we go to the demo, so this is the architecture, right? So behind the scenes, there is a lot of data engineering happening. So what we did is we deployed to Airflow over a compute engine, and I will try and walk you through the decks. So these are the 4 pipelines. As we discussed that there are 4 data sets taking picture to create this chatbot. First, we have insurance plans. So all the details relating to what the insurance plans are, which insurance issuers give those plans, and possibly what are their premiums, what are their deductibles. All the data for this is coming from this pipeline. So ideally, US government, they all on a yearly basis, they release a link. What users have to do is they just have to trigger this DAG pipeline. And once they do that, they select the year which they are selecting, and they just have to point it to that government website. As soon as we do that particular thing, the pipeline is smart enough to divide that data into proper chunks. Chunks meaning we divide the data as per the semantics, like premiums rate data into its own table, deductibles data into its own table. So this was one of the pipelines. Similarly, we have benefits. So if I am a person who cares more about heart benefits or maybe knee benefits, because I face those kind of diseases on a regular basis. So I need to know what the insurance plans are. So this pipeline gets me that particular data. Certain people care more about the prescription drugs. So if a particular drug is more important to them on a day-to-day basis, the insurance plan which support those drugs, the information will be coming from me. And then we have ratings. So this was all about the data engineering part. Now let us walk through the demo.
Hello everyone. So this is the look of our application, and you can see we initially we need 3 different kinds of inputs from the user to make sure that the information which we are providing is coming for the right region and the right use case which he is looking for. Because there are multiple insurance issuers present in different states and have the same insurance plans overall different state, but have different prices for according to the regions. So over here, let's take like if I'm taking Alaska. So once the state is entered, you can see all the counties will get enabled. We are doing county. If you have a plan ID with you, you can put the plan ID so that the chat knows that this is the particular plan you are looking for and the information you are looking at. If you don't have a plan ID and if you want to know about new plans which you want to take it for 2024, you can just keep it blank and proceed. So once you proceed, you can see the chatbot is activated, and it provides you with 3 different types of suggestions that provide me insurance plan that covers drugs like ethanol, which is a hard drug, which is pretty expensive and most commonly used drug towards insurance, like which is claimed through insurance. The second suggestion, which goes like, give me 5 plans with the cheapest premiums for couples, list plans that cover dental insurance. Other than these feedbacks, you can also write the text which you want. So let's start with the basic one. Give me issuers that can provide the insurance. So while this is going, so in the back end, what is happening is this particular query will hit an OpenAI model, which is built on top of Langchain. So the first OpenAI model will create an SQL query. It will shoot that SQL query in the Snowflake, validate if the SQL is right or wrong. If it's wrong, it will send back to the OpenAI. If it's right, it will generate a data and it will send to the other model, which is acting as a insurance agent and give the insights on top of the data which is provided on it. So as you can see, it provides me that there is one issuer in your particular region, and it has these particular plans. So now what I can ask is, if the user is married, I can ask, give me the cheapest insurance plan for me and my wife with age, because the insurance plan rates changes through ages. So we are providing ages as well, like 36 and 34. And we have 2 children. So when we are putting this, this will go back to the database, and here the main thing which was challenging for us is to ask an OpenAI to give only the SQL query, not any other context, and format the output of a particular OpenAI. As along with that, when we are asking for suggestions, it is providing us different suggestions based on the questions which we are asking. So now it has provided us with the cheapest insurance plan you have provided, and it is also giving us suggestions that what are the coverage details for the family plan offered by this particular issuer, or what are the premium cost and what are the additional benefits or discounts available. So we can click on that. It takes that particular question, asks it back to the OpenAI. So here the main idea behind this particular chatbot was to let the user know more about the insurance before purchasing, or if he has his own insurance with him, he can know more about it. Means if by any chance, if he had an accident, if he wants to check if this insurance covers this particular thing, you can go and check for that particular things in this particular chatbot. So here you can see it has provided the additional benefits and discount available with the family plan from the issuer, include coverage, routine detailed dental services, hospital services, and other all benefits. So you can also ask the OpenAI to provide other issuers with like other insurance plans and what are the list of it. Like if you want to check which are the other plans. So which are the other plans in the provided by the issuer. So here you can see I'm not giving the chat any names, any plan IDs. It is automatically taking all the information from the memory which it is going through in the chat. And as we are running two different chat models, it is not even giving any wrong information or any different type of information. That is. So here you can see it provided us with other insurance plans as well. And now if I'm doing for example, I want to compare. So can you provide me?
So just like what's actually happening here? Like, I mean, are you calling specific prompts or like what I'm trying to follow?
So here in the backside, what is happening? This particular prompts which we are sending to it, sending through the chat is going to the OpenAI. It checks through the database which has around 256 to 300 different columns, and the dimension is in fact around 100 and how much is the row size for that?
1 million records.
More than 1 million records. It fetches the appropriate data which is available for that particular so what is it in the particular data set. It grabs that particular SQL, creates an SQL on top of it, and then sends it to an agent who can do research on that particular data and provide insights on top of it.
Yeah, so a lot of prompt engineering was done, Professor, to gain this. We don't see the SQL query right here because it is an end user facing application. So it does all the hard work at the end. One of the key challenges while building this chat application was OpenAI did not understand the columns. So we had to manually go through the columns, write long names so that OpenAI understand what is happening in there. So metadata, creating prompt, judging if the SQL queries are right. Behind the scenes, everything is encapsulated, but the chatbot gives you all those suggestions seamlessly.
Along with that, when a response is coming back, the response is coming back with two different elements. So we have engineered the OpenAI in such a way that the OpenAI will just provide us with a JSON string in which the first key would be the answer for the question which we are sending. And the second key would be the follow-up question based on the information which he has received from the conversation which we have. So which provides us, which gives a user a pretty good experience to know which questions you want to ask. And the agent has been trained in such a way that if you are providing in such information, what would be the questions which a user would have? So it provides in such a way, it gives that particular responses.
Thanks. Next, we're going to have team 8.
Since the instance is not running properly, I'm trying to show it to you locally. Yeah, so just want to share access also. I'm already in the meeting. I don't see I am in the meeting. You are, I think he's not on the panel list.
No, you don't need a panel, you just write.
Hi.
Upgrade them to panel, promote them.
Okay, oh, that's. Got it? Or that's.
They just, them share, then remove them from the panel. So you right click on that person and then say make more.
So basically, our project was to focus on the deaf and blind people. We made an application where we are providing the YouTube links, which is being converted into text. And then we are summarizing it, we are transcripting it, and we are also generating quizzes and audio quizzes. So the architecture was, so we obtained 4 to 5 lists. We made a 4 to 5 list a database. We stored it, and using Airflow, we did the transcription. We used the PyTube library. Using OpenAI, we summarized the text. We used Hugging Face library for language translation, and again OpenAI for quiz generation. We use Google text to speech to create audio playlist, and all this data was again stored in a database, and it was connected to the Streamlit using FastAPI. So basically, when we were extracting the YouTube links, so when we give a playlist, this is the typical format of any playlist. And when we have to access the first or second video, this index thing is the primary thing which we look at, and using this we extracted 4 to 5 videos linearly, and we combined Airflow and FastAPI to do all this, and we were successful for user registration, selecting the video, summarization, quiz generation, and generating audio quiz playlist. This is the data we have on our Postgres database. So this is some code snippets. First one is when we get the one YouTube URL, we are like temporarily storing it when we are extracting the audio from it, and then we are providing audio further to transcribe it. And then we are using speech recognition library, which is like recognizing the speech, and then it is converting it into text. And amid all this, you might be wondering that how a long video can be like converted into text. So what we did was whenever there was a pause, we like made chunks out of it, and we processed it individually, and then we like appended it as a bold text. So this bold text was provided as a context for OpenAI, and then we did write one prompt where the bold text was given as context, and further for generating quiz question and options answer explanation, it was like properly sliced, and it was further generated. And after the user has attempted the quiz, he'll get the correct options and the wrong options, and also he'll be able to see the explanations. In audio playlist, it is all like spoken. So I will show the demos.
Yeah, so we have a user login over here. And we're students. So we have pre-processed 2 playlists, which has we have taken 5 videos each. One is the Light Road series, and there's one more other playlist.
These 10 videos have been pre-processed using Airflow, and there were a lot of complications while doing that too because of the disk size. And just see what we can do once I have selected the video. So in this video, I can get the entire video's transcribed text over here. This is basically end-to-end, everything is coming over here. We have created a summary option. Those who don't want to go through everything, and they can just like this summary is being generated by OpenAI. And then we have the quizzes option over here. This quiz has been created using OpenAI as well, using the same video which is processed right now. So yeah, so if I just answer this and submit it, it tells us if it's correct or wrong. And yeah, even if I just like go and resubmit it, yeah, that's right. For the blind people, there's a audio like text to speech conversion over here. So the same question has been converted into two playlists. The first playlist has the questions, and the second one has the answers to it.
For one, what is the primary purpose of responsibility placed on the user when choosing whether to use chunking or streaming for batch steps?
Yeah.
Options are option A, to ensure the batch step is set up correctly. Option
Yeah, and just move to the answer one.
For question 1, the correct answer is option B,
Yeah.
to ensure the batch step is optimized for performance.
So yeah, that was the demo.
What is the value is it summarizing specific pages or?
No, it's so first of all, it's transcribing the YouTube video audio which is coming there. Then for getting a summary of the entire video because it's a big video. So that's over there. And then we are creating the quizzes from that so that it's a learning platform over there. For the deaf people, they can read it through and answer over there. And for the blind people, we are converting them to audio, two files. First one is basically the questions, and second one is the answer, so that it's kept separately and they can like attempt to answer them. So that's how it is processed, like the flow.
Okay. The quizzes are all graded
Using OpenAI. I can show the code if you want to.
Always for the prompt.
Yeah. There's some prompt work he has done on that. Yeah, here. We can also change the difficulty. For now, like we wanted to make sure that everything is working, so we have kept it easy. But that can be also what do we say, generalized, and we can create multiple quizzes based on the difficulty level also. And we have checked it on Collab, it's working. It gives us different difficulty level quizzes as well. But in order to
This prompt was designed in such a way that the questions, the answers, correct answer and the explanation can be properly like truncated, sliced, and it was like for the easy for processing.
it was giving some issues while parsing it to front end, but we had to like arrange it properly and then send it to front end so that it can be displayed properly on UI, like an interactive platform where the answers can be put and answered and get an answer, like correct answer, wrong answer.
Cool, thank you.
Yeah.
Okay, so the final team 5. Okay. Let's go team 5.
Good evening, everyone. Today, me and my team, Anamika and Shruti, we are here to present our project called Shakespeareify. We see that our literature is a big part of our culture, and it's because of how old it was, we are losing interest in it. So our app is here to save that literature. So Shakespeare, we've taken place from Shakespeare, and we have illustrated it to make it more interactive and for people who don't like to read Shakespeare, and the younger audience will be able to really relate to the content. We've also made this project for upcoming illustrators who want ideas for their books, how they're going to create their illustrations, so they can put in their EPUBs, their books, and create their own illustrations. So here is what the demo looks like.
So this is the website. So here, all the pictures that you can see are from the default plays that are already uploaded into the system and have been created by Stable Diffusion through our architecture. So let's go on to start your adventure. So here we can, under plays, under the tab plays, you can see all the preloaded plays that we have. So for example, so what we have done is we have taken each chapter from the play Macbeth, and then we have made a illustrative comic book out of it. And in true comic book style, we also have an description under each illustration to explain what's going on in this comic book. So again, for example, Romeo and Juliet. So what we're doing is we're making chunks out of it. We're using OpenAI to make prompts, and then we are using Stable Diffusion to make the comic book. So as you can see, Romeo mingling in the crowd, Romeo approaching the fair lady. So as Sanya, my teammate, said, we have also created a feature where we can upload an EPUB. So,
so let's upload one EPUB and see. We'll go with Alice in Wonderland now. As soon as the EPUB file is uploaded, we get like a list of all the chapters that are in the file. We can pick any chapter, and when we click on generate comic,
it takes a little bit of time.
Yeah. Now you can see like the comic for this particular chapter has been created. It has like all the prompts and the images together. We also have the option to change any particular image that we want, so that the user can change the art style if they want. So all we have to do is we have to take this prompt, and we have to add this prompt here, and we have to adjust a few things, like for example, steps. Steps is basically how many times we want the diffusion to happen. CFG scale, that kind of checks how closely the image will be creating with the prompt, and seed. And once we click on regenerate, we can see here that the photo, which was looking, we have a comparison here, looking like this, has been now changed to something like this. So user can choose anything that they want, and then accordingly the whole like image changes. So for example, if we go with pixel art, so here the prompt is a queer looking party of birds with dragged feathers and animals with their fur clinging close, and we have like it in the pixel art set.
So since stability diffusion is a little expensive, so we thought that we can allow people to check if they like the image, the image style, the CFG, if that is working for their own taste with only one picture first, and they can, and it just changes that particular picture in the whole grid.
So what is OpenAI doing, and what is being sent to OpenAI generating the prompt? So you're providing a specific summary, or like how are you chunking the storyline?
So for example, if you take a chapter from a book, it is divided into segments. And then we put these segments individually into OpenAI, which chunks the segment further and creates, for example, with one chunk, it'll create 5 prompts. And that's how it goes. Okay. And then those prompts are sent to Stability AI, and that produces the images.
And you're storing them where?
MongoDB. So we have used S3 bucket where we have stored all the images and the links are generated. And so the MongoDB stores the image link along with the prompt, and that's what is interacting with our FastAPI.
Okay, cool. Thank you.
Thank you, sir. Thank you so much.
Okay, guys, so that was it. I mean, we had all the 8 presentations. I mean, really cool presentations. Obviously, we have to kind of, do our due diligence of looking at the architecture, the implementation, the testing, the documentation, how much effort you're actually put in, or you're delegating everything to OpenAI. So we got to look at everything before we can, finalize the grades. But I'm glad that you were able to accomplish all the project proposals and the objectives. So we're going to evaluate you based on what you proposed and what you delivered. So there were some minor hiccups, but that's fine. I mean, but, most of the core goals of the projects were kind of accomplished. So good luck with everything. This is like the final day of the class. So enjoy your break, and we will see you soon. And for people online, thanks for making time for the presentation. I know a couple of you had reached out with some questions. Please contact us online. And we also posted links to the GitHub on LinkedIn, so people can actually go and look at the code and reach out in case there's an interest. But there are some specific technical questions which I'm not going to go and delving into. But if you have any interest in talking to any one of our students, please reach out to us. That way we can put you in touch, and then we can follow those discussions. Thanks again, and have a wonderful